For this problem, we are going to solve the cotangent of 3x equals 1 for x greater than or equal to 0 degrees, less than 360 degrees, and then we're going to verify the answer graphically. The cotangent of an angle is the reciprocal of the tangent. So we're going to rewrite as 1 over the tangent of the 3x equals 1, or the tangent of 3x equals 1 as the equation that we're going to work on. Recall the tangent function and the cotangent function has a period of 180 degrees or pi. So for the angle 3x or the argument 3x, which is the angle between 0 degrees and pi or 180 degrees, tells us x will be between 0 degrees and 60 degrees. Or we can say that the period for this cotangent 3x gonna be 60 degrees. To solve for an angle 3x, recall the tangent is positive, will be in the first quadrant. The first quadrant because the original period gonna be just the pi or the first half of the revolution. Gonna be quadrant 1 or quadrant 2 from 0 to pi. And the positive tangent will be in the first quadrant. Then we have the 3x equals 45 degrees. As a general version, the 3x equals 45 degrees plus the multiple of original period, which is 180 degrees multiplied by k. When you solve for x, we have x equals 15 degrees plus 180 divided by 3, which is 60 degrees times k. That turns out to be the same number that we analyzed at the beginning. This one is in the form of the all solution of this problem. Okay, for the all solution. And the problem asks us to solve if x is between 0 degree and 360 degree. For 360 degrees is 6 times of 60 degrees. Therefore, for x between 0 degrees and 360 degrees, gonna contain the 6 cycles of this graph. So we're gonna use k equals 0, which is original cycle, and then k 1, 2, 3, 4, and 5 to gain another set of the solutions. So for k equals 0, which is the first cycle, x equals 15 degrees, k equals 1. I'm going to put a note here. This is the first cycle. And then for k equals 1, x equals 15 degrees plus 60 degrees. That turns out to be 75 degrees. So this is the answer in the second cycle. And k equals 2. We'll get x equals 15 degrees plus 60 degrees times 2. That gives us 135 degrees. That is the solution for the third cycle. And keep going the same manner. For k equals 3, x equals 195 degrees. This one is the fourth cycle solution. And k equals 4 will be x equals 255 degrees, which is the fifth cycle solution. And the last one, when k equals 5, x equals 315 degrees. As you see, when you keep adding by 60 degrees, you're gonna get another solution until you hit the number that is less than 360 degrees, or within the bound of the solution that the problem asked you to find. The last one here is the solution for the sixth cycle. So we get 6 solutions for this problem within the interval 0 degrees and 360 degrees. So now I'm going to show you the graph. On your calculator, make sure that the mode is in the degree mode. And then you go to the y equals function, type in the first function as cotangent of 3x, which is the reciprocal of the tangent. So we're going to type in 1 divided by tangent of 3x, close the parentheses. That's the first function. Let's check on the graph. The graph will look like this. Let's check the window because we need the x min 0. So change it to 0. X max is 360 degrees, the increment. And let's change the y minimum to lower number, which is -5, and the y max as +5, and hit the graph again. So we can see in the expanded form of the graph. And then you see we're going to have like 6 cycles from 0 to 360 degrees. And next we're going to type in another function. Oops, I already deleted. So let's retype it again. So 1 divided by the tangent of 3x, close parentheses, and then we're going to move the cursor down and type in another function, which is y equals 1. Our goal is to find the intersection points of the two graphs, or the graph of the cotangent 3x and the graph of y equals 1. So let's hit the graph button, and we can see that there are 6 intersection points from the angle 0 to the angle 360 degrees. So in summary, we have 6 solutions as x equals 15 degrees, 75 degrees, 135 degrees, 195 degrees, 255 degrees, and 315 degrees as the solutions for this problem.